So two things important. First one is electron withdrawing group. Two things important. First one is electron withdrawing group, and second is a good leaving group. Second is a good leaving group. So these two things are important for nucleophilic aromatic substitution reaction. These two things are important for nucleophilic aromatic substitution reaction. So you can see, because there are 3 pi electrons, so they not normally, they behave like a nucleophile and they cannot react with the nucleophile. They cannot give any reaction. But I already told, if there is strong electron withdrawing group at ortho and para position, then they decrease electron density from benzene ring, right? And when they decrease electron density from benzene ring, right? So then due to deficiency of electron, they can react. They can react with a benzene ring. Then they can react with a benzene ring. So you can see here, right? And second important thing is there should be strong leaving group, right? There should be strong leaving group. So if a strong leaving group, they can easily leave out, right, with electron, right? And then this is electron deficient. You can say that this is electron deficient substrate, and then they can easily react with upcoming or new nucleophile, right? Then they can give this types of nucleophilic aromatic substitution reaction. We have already discussed. This is bimolecular reaction, and we can say it is a second order reaction. It is bimolecular reaction, or it is second order reaction, because the first step is slow step. First step is rate determination step. And in first step, leaving group leave out and nucleophile attack, right? Because in first step, nucleophile attack at our वहां पे क्या होती है, दोनों चीजें होती है, राइट? यू कैन सी, बिकॉज देयर इज बोथ थिंग्स आर साइमल्टेनियसली गोइंग ऑन, राइट? क्योंकि वहां पे दोनों की दोनों चीजें साइमल्टेनियसली चलती रहती हैं, इसलिए, राइट? दिस इज रीजन, राइट? इट इज कॉल्ड बाइमोलिक्यूलर रिएक्शन एंड इट इज कॉल्ड सेकंड ऑर्डर रिएक्शन. इट इज कॉल्ड बाइमोलिक्यूलर रिएक्शन एंड इट इज कॉल्ड सेकंड ऑर्डर रिएक्शन, राइट? इसलिए इसे बाइमोलिक्यूलर रिएक्शन भी कहते हैं, एंड इसे क्या कहते हैं आप, सेकंड ऑर्डर रिएक्शन भी कहते हैं, राइट? दिस इज ए रीजन बिहाइंड दैट, राइट? तो ये चीज भी आपको क्लियर होनी चाहिए, व्हाई इट इज कॉल्ड सेकंड ऑर्डर रिएक्शन. बिकॉज न्यूक्लियोफिलिक एरोमेटिक सब्स्टिट्यूशन रिएक्शन, बिकॉज nucleophilic aromatic substitution reaction are mainly 2-3 types, right? I will discuss some other types also. This is about bimolecular reaction. You can see this is about bimolecular reaction, right? Where in first step your nucleophile attack at substrate and that convert into this types of intermediate, right? So they convert into carbocation. Then I have already discussed, right? They give a resonance structure. First negative charge come at this ortho position, then they come here, and then they come go there, right? This way 3 resonance structure. Out of that, this is most stable intermediate. It is a most stable intermediate, right? And because if electron withdrawing group at para position, then that is a most stable intermediate. So it means para position is suitable for you can say that nucleophilic aromatic substitution, right? Or you can say that ortho position. Not only para position but also ortho position is the best position for electron withdrawing group. If electron withdrawing group exists at ortho or para position, electron withdrawing group exists at ortho or para position, right? So then that give a stable intermediate, right? And if they give stable intermediate, it means those positions are best for nucleophilic aromatic substitution reaction, right? So these positions are best for nucleophilic aromatic substitution reaction. Now you can see here, right? Now you can see here, it is if you can see negative charge when nucleophile attack at this position, then nucleophile come at this position, or in their resonance form. In their resonance form, you can see they come at this position, they come at this position, or they go at this position, right? So it means there is a possibility of 3 types of position. You can see, then there is a possibility of 3 types of position, right? Either they come at two ortho position, this is ortho position, this is ortho, and this is para position, and either they go at two ortho position or para position, right? So you can see if electron withdrawing group, I already told, if electron withdrawing group exists at two ortho and one para position, ortho position or para position, then they give stability to our intermediate, right? Then they give stability to our intermediate, right? And when they give stability to our intermediate, it means that is a slow step, right? And it means we required electron withdrawing group for nucleophilic aromatic substitution reaction, right? So this is the point which we had already discussed in our previous class, right? Why para position is the best position, because when nucleophile attack here, their negative charge come at two ortho and para position, and this intermediate, this resonance structure is the most stable intermediate, right? So they prefer para position. You can see meta position. If you see this position, meta position, if your electron withdrawing group at meta position, then you can see nucleophile when attack here, right? So then negative charge come at this position, negative charge come at this position, negative charge. Then there is no one most stable intermediate. There is no one most stable intermediate. You can say there is no stable intermediate, right? So if they not give any stable intermediate, it means this position is not suitable for electron nucleophilic aromatic substitution reaction, right? तो इलेक्ट्रॉन विड्रॉइंग ग्रुप की जो मेटा पोजीशन होती है वो सुटेबल नहीं होती है न्यूक्लियोफिलिक एरोमेटिक सब्स्टिट्यूशन रिएक्शन के लिए, राइट? इट शुड बी क्लियर बेस्ड ऑन दीज रेजोनेंस स्ट्रक्चर, राइट? तो इन रेजोनेंस स्ट्रक्चर के बेसिस पे आप ये चीज क्लियर कर सकते हो कि दीज पोजीशन आर नॉट बेस्ट, राइट? Now after that we had a discussion on elimination addition reaction, right? In nucleophilic aromatic substitution reaction, first type mechanism is called addition elimination, and second is called elimination addition. This is called addition elimination. You can see this is called addition elimination mechanism, because in first step addition and in second step elimination, right? पहले स्टेप में क्या होता है, एडिशन होता है, और उसके बाद वाले स्टेप में क्या होता है, एलिमिनेशन होता है. इसलिए इसे कहते हैं एडिशन एलिमिनेशन स्टेप, एंड it is a second order reaction, right? ये क्या होती है, second order reaction होती है. So two things are very important here. You can see their order, and second thing is the first step is addition and second step is elimination. Now after that you can see, if I talk about this mechanism, so this is called elimination addition mechanism. Now what about elimination addition mechanism? So you can see here ring is not activated, right? And the nucleophile is extremely good one, right? So if your ring, this ring is not activated, it means there is not activated group, right? You people already know which one is activated group, right? तो आपको पहले से पता है activated group कौन होगा, जो बेंजीन से इलेक्ट्रॉन्स को विड्रॉ करेगा और बेंजीन को स्टेबिलिटी नहीं देगा, right? So you know this X halogens are not electron withdrawing. Their negative inductive effect nature but positive resonance effect, so it does not behave like a good electron withdrawing group or activating group, right? तो जो आपका X होता है, हेलोजेंस होता है, तो वो क्या नहीं होता है, अच्छा इलेक्ट्रॉन विड्रॉइंग ग्रुप नहीं होता है, क्योंकि वो वैसे तो नेगेटिव इंडक्टिव इफेक्ट दिखाता है, मैंने पहले भी कहा था, बट बिकॉज वो पॉजिटिव रेजोनेंस इफेक्ट को भी दिखाता है, वो इलेक्ट्रॉन्स को बेंजीन रिंग को पुश करता है, राइट? तो इसलिए दिस इज रीजन दैट इज नॉट ए गुड यू कैन से दैट एक्टिवेटर. Mechanism, then they can never give this mechanism, right? But you can see here network problem, because morning I was in a conference, right? And then I think maximum net, right? I was there. You can see here the nucleophilic aromatic substitution reaction, right? If I talk about this, right, to here what is basic requirement? First requirement, a haloalkane, right? Where not any activated group. But second important thing which is basic requirement for this reaction is a good nucleophile, right? How we get a good nucleophile? So you can see, if suppose that we have sodium amine, right, NaNH2. If suppose that we have sodium amine NaNH2 or potassium amine, right? So potassium amine and sodium amine easily give NH2 minus ion, right? They can easily give NH2 minus ion, and NH2 minus ion behave like a good nucleophile, right? NH2 minus ion behave like a good nucleophile, because you know NH2 potassium ion or sodium ion is a good ionic compound, right? They can easily dissociate into K plus and NH2 minus, or Na plus or NH2 minus, right? So then they can easily give NH2 minus ion, right? And that behave like a good or extremely good nucleophile, right? So if they attack, right, if they attack, right, then X minus will leave out, right? And the reaction takes place in presence of NH3, right? And this reaction takes place in presence of ammonia. This reaction takes place the reaction takes place in presence of NH3, right? So for this reaction, we require NH3, right? For this reaction, we require NH3, you can see, right? And then finally, they convert into aniline. And finally, they convert into aniline. So this is one of the important reaction, right? Now, what about their mechanism? Now, what about their mechanism? I have already discussed their mechanism also in my previous class. First step is elimination step, and then second step is addition step. Important thing is that the first step is elimination step and second step is addition step, right? So now how they give addition step, right? So how they give addition H2 minus, right? That give easily give NH2 minus, right? You can see here, a little bit difficult. Network problem. There is a network problem, right? So you can see, right? So here first, this is your hello benzene, right? You can see this is your hello benzene that react with NH2 minus, that react with NH2 minus. And when they react with NH2 minus, then you can see here, right? Here H react with NH2 and move out like a NH3, right? Move out as a NH3, right? And then NH2, right? Because when H plus will move out, then there is a sigma bond, and that sigma bond convert into a negative charge. That sigma bond convert into a negative charge, right? This is very simple reaction. And in first step, right, their removal of H plus ion. In first step, their removal of H plus ion. So it is called elimination step. So it is called elimination step, right? Then after that, in second step, you can see, right, this intermediate carbanion, right? This intermediate carbanion lose their X minus, right? In this step, actually, it is a part of first step, right? X minus, they remove out X minus, right? And then you can see when X minus will remove out, then you can see when X minus will remove out, right? You can see when X minus will remove out, then after that, when X minus will remove out, then this sigma bond, then this sigma bond convert into pi bond. This sigma bond convert into, because here X minus will remove out, then this sigma bond or this negative charge convert into a pi bond, right? This negative charge convert into a pi bond, and then they convert into a very important intermediate, and the name of intermediate is benzene. And the name of intermediate is benzene, right? So then they convert into this intermediate, and this intermediate is called benzene, right? So this is actually first step where removal of X minus and H plus. We can say SHX will remove in first step. You can say HX is removed in first step. You can say this step. You can say this step is elimination step. Now after that you can see next step after elimination. Next, what about next step? The next addition. So it is called addition elimination reaction. You can see now this benzene intermediate react with NH2 minus, same like this, right? This benzene react with NH2 minus, right? And when that react with NH2 minus, you can see now there is a addition reaction. Now there is a addition reaction. NH2 attach at this point, right? NH2 attach because negative charge. So negative charge convert into sigma bond. You can see here, right? So now here NH2, right? And then negative charge come at this point, right? Negative charge come at this point. Now, right? Next step, your NH3 attack at this negative charge, and then they convert into, then they lose their H plus ion, right? So NH2 minus as it is remove out at the end of reaction, right? So at the end of reaction, you can see NH2 minus will remove out and NH3 give their H plus here, and they convert into aniline. They convert into aniline. So you can see in second step, first addition of NH2 and then addition of H. It means NH3 will add, right? So you can say second step is addition step and first step is elimination step. So overall, we can say this reaction is elimination addition reaction, right? So if anybody asks you, what do you mean by elimination addition mechanism? So you can say it is benzene. It is also called benzene mechanism because during this process, benzene formed as a intermediate. Because during this process, benzene form as a intermediate, right? So you can clear, right? Addition elimination mechanism. What do we mean by addition elimination mechanism? So this is one of the important nucleophilic aromatic substitution reaction, right? This is one of the important nucleophilic aromatic substitution reaction. And it is part of your syllabus also, right? And it is part of your syllabus also. Oh, okay. Now after that, our next discussion, according to your syllabus, next types of mechanism in aromatic nucleophilic substitution reaction. This is called Sn1. Now what do we mean by Sn1? So it is very clear, right? In aromatic nucleophilic substitution reaction, there is also first order nucleophilic substitution reaction. It means there is also first order nucleophilic substitution reaction. It means in first step or in slow step, there is only one substrate is important, right? If we change concentration of substrate, then rate of reaction change. But if you change concentration of attacking group or nucleophile, then the rate of reaction not change, right? So this reaction is called first order reaction. Now our discussion on Sn1 type mechanism. It's a very important mechanism in aromatic compound, right? So which types of compound give, right? Which type of compound give Sn1 type reaction? Actually, benzene diazonium compound or benzene diazonium ion. Benzene diazonium ion give Sn1 type mechanism only, right? These are rare reaction. These are not find in majority, right? They are a rare reaction and a special types of compound you people already know, benzene diazonium chloride or benzene diazonium ion, right? So benzene diazonium ion give this mechanism which is called Sn1 type mechanism. You can see it is an unstable compound, right? Benzene diazonium ion is an unstable compound, right? So when you apply heat, when you give energy, then they convert into, you can see that this types of benzene cation. They convert into this types of aryl cation. You can see that aryl cation, right? Benzene diazonium ion convert into aryl cation. During that process, nitrogen gas will evolve out, right? During that process, nitrogen gas will remove out, right? So nitrogen gas will remove out during this process. And after this is first step, this is slow step, rate determination step. And during this step, only benzene diazonium ion react, because during this process, only benzene diazonium ion react. So, right, this is region. So, and this is region. It is first order reaction. So, this is region. It is first order reaction. You people can see here, right? You people can see here benzene diazonium chloride, right? Benzene diazonium chloride ion, right? Give this this types of intermediate, right? Benzene with negative positive charge, right? Benzenium ion, right? And during that process, nitrogen gas remove out. During that process, nitrogen gas will remove out, right? And because in first step only one reagent participate, only one reactant participates, so it is called first order reaction. And then you can see once they convert into aryl cation, right, then they easily react with nucleophile. Then you can see that is easily react with nucleophile, right, and nucleophile attack on this position because there is a positive charge, right, and then they finally convert into this types of nucleophilic aromatic substituted product. So second step is very fast, you people already know second step is very fast, right, and during that process is simple addition reaction, Nu minus attack at plus charge and they convert into nucleophilic aromatic substituted product, right. So sometimes people may ask you what about S aromatic Sn1 type reaction. So you can give this mechanism, right. Rare case benzene diazonium cation only give this types of mechanism where they follow first order reaction mechanism, right. Now after that, next point of discussion. Okay, now next point of discussion. This is a very important reaction. This mechanism also very important. Sometimes people ask reaction related to this reaction also. Unimolecular radical nucleophilic substitution reaction. Now the point come, right? This reaction follow radical mechanism, right? Unimolecular. First point is unimolecular. It means first order reaction, right? And radical means during this reaction free radical form, right? And it is nucleophilic substitution reaction, aromatic nucleophilic substitution reaction. You can see here S means substitution, R means radical, N means nucleophilic, 1 means unimolecular, right? So we are talking about the aromatic unimolecular nucleophilic substitution reaction with free radical, right? So now how the reaction proceed, you can see here how the reaction proceed. So first of all, it should be clear, in first step or in initiation step, solvent electron, right, initiation step, right, start from solvent electron, right. So solvent give one electron, that electron initiate our reaction, right, and you people already know when electron initiate any reaction, then their formation of free radical, right. Sometime it is a photochemical reaction, sometime it is electrochemical reaction, sometime it is thermally reaction, right. So there are so many way, or there are so many source by which your solvent release electron, right. There are so many way from which your solvent release energy. Sometime in photochemical condition, sometime in photochemical condition, it means when you give one photon energy, then the solvent release electron, right. Electron excited from down state to excited state, and then they can lose electron for a nucleophilic aromatic substitution reaction. तो sometime क्या होता है कि photochemical condition responsible होती है सॉल्वेंट से इलेक्ट्रॉन को लूज कराने में, राइट, कि जब फोटोकेमिकल HNO1 फोटोन एनर्जी आएगी तो फिर आपका सॉल्वेंट मॉलिक्यूल उस 1 फोटोन एनर्जी को एब्जॉर्ब करेगा और फिर उस 1 फोटोन एनर्जी से आपका जो सॉल्वेंट मॉलिक्यूल होगा वो एक इलेक्ट्रॉन को क्या करेगा, रिलीज करेगा, राइट. तो समटाइम दिस इज कंडीशन for solvent electron for release out solvent electron. Sometime electrochemical energy, right, sometime electricity or electrochemical energy, when you give electricity or electrochemical energy, then they interact with your solvent molecule and then your solvent molecule easily release one electron, right. So this is sometime condition, right, or sometime condition thermal condition. Sometime if you apply heat, right, if you apply heat and if you give thermal condition, so then in presence of heat, right, solvent give or solvent lose their electron, right, and that electron is a key of unimolecular radical nucleophilic substitution reaction because it is initial step, right. You require solvent electron. Once you get solvent electron, then that solvent electron react with haloalkane, right. Here same like you can say that benzene mechanism. Here also important compound, right, which is not activated, that is halobenzene. They may be chlorobenzene or bromobenzene or something else, right. So halobenzene when react with solvated electron, then they convert into free radical. When electron come here, right, so then that electron come in the form of radical. You know, if unpaired electron with any molecule, then that is called free radical, right? If unpaired electron with any molecule, then that is called free radical. And you people already know X means halogen, right? That is highly electronegative element, right? You know, X is highly electronegative element, so they can take electron. So they can take electron, and when they can take electron, then they convert into radical ion. Then they convert into radical ion. So this is initial step where first, with help of photochemical condition or electrochemical condition or thermal condition, right? Your solvent lose one electron, then that electron react with your halobenzene, right? Where halo or your chloro or bromo, right? That is highly electronegative atom, right? Halogens, and they can easily pick that electron, right? And convert that into a radical ion. They can convert that into a radical ion. After that, this radical, right? After that, this radical lose X minus, means X with this bond, with sigma bond, right? This sigma bond move out with X, right? So it means X minus will leave out, and then this negative, this free electron come at benzene. This free electron come at benzene, and they convert that into aryl radical. Then they convert that into aryl radical, right? So this is also important step. First, that convert into this types of radical, then they lose X minus and convert into aryl radical. Once aryl radical form, then nucleophile attack at this part. Nucleophile attack at this part, and free radical, right, or unpaired electron come at Nu, right? Unpaired electron come at Nu, because negative charge convert into sigma bond, right? Then left only unpaired electron at Nu, right? So this is a radical ion, right? This is also a radical ion. This is radical ion, and this is also radical ion. Here X and here Nu, right? Now after that, you can see, right, this is a termination. You know, free radical, when we talk about free radical reaction, when we talk about free radical mechanism or free radical reaction, then there are three steps. One is called initiation step, then second is called propagation step, and third is called termination step, right? So three steps are important in free radical mechanism. So here also this mechanism follow radical mechanism. So first step, there is initiation, then second step, there is propagation. I will discuss free radical mechanism in coming PPT also, right? So initiation step, then propagation step, and then in terminate. In termination step, this compound or this radical ion react with the next molecule of chlorobenzene or bromobenzene, right? Then you can see they convert into this types of product. They convert into this types of product, right? Because here this radical come with X and they convert into radical anion. It means then the long cycle can form, right? This is your final product, nucleophilic aromatic substituted product, and this radical ion used for a long reaction or for the formation of so many types of product molecule, right? For the formation of so many types of product molecule, you can use this, right? So this is a use in a propagation step. You can see propagation cycle continue. It means this radical we can use for for the synthesis of so many types of product molecule, right? So many types of product molecule. So this is about initiation step, then propagation step, and then termination step. So this is about aromatic. You can say that this is important mechanism which is called unimolecular radical nucleophilic substitution mechanism, or SRN1. Sometimes people ask question on SRN1, right? What do we mean by SRN1, right? So this is one of the important mechanism in aromatic nucleophilic substitution reaction, right? So first one mechanism, bimolecular mechanism, right? Sn2 type mechanism, right? Then second mechanism is benzene mechanism, right? Elimination addition mechanism. Then third mechanism is Sn1 type mechanism. Then fourth mechanism is SRN1 type mechanism. So these are most important